Hello, YouTube. Alright, so today's going to be a little bit of a long lesson. So please just follow along with the worksheet and then you will have 2 pages of homework to do at the end. Today's lesson is Lesson 1, Introduction to Probability and Sample Space. Let's read this through. The probability is a likelihood of an event happening in a probability experiment, which is any activity involving chance. It can be like flipping a coin, rolling a die, or spinning a spinner. For instance, probability of flipping heads on a coin should be 1/2. The probability of rolling 1 on a die is 1/6. And the probability of rolling green on this spinner right here is 1, 2, 3, 3 out of 8. I'll show you how I get this very, very quickly. Now, an outcome is a possible result in a probability experiment. When you flip a coin, the possible outcomes are heads and tails. For rolling a die, it's 1, 2, 3, 4, 5, 6. And in this example, there are 3 colors: green, red, blue. Is that it? Green, red, blue. Yep, that is right. Now, this list of all possible outcomes is called a sample space. So the sample space of flipping a coin, example 1, is heads and tails. Sample space of rolling a die is 1, 2, 3, 4, 5, 6. And the sample space of spinning this spinner is green, red, and blue. Now let's consider the situations below where the possible outcomes of flipping a coin, rolling a 6-sided die, or spinning the spinner below. I already did that for you guys. Sample space, sample space, sample space. Now number 1, you wrote out the sample spaces for simple events. In compound events, 2 or more probability experiments occur, which means that finding the sample space requires more thoughts. For example, how many different outcomes could occur if you flip a coin and roll a 6-sided die? There are different ways to show all the possible outcomes, or the sample space. For instance, here's a way to do it. Here's a tree diagram to show you how to get the sample space of a coin and a 6-sided die. Let's start off with the coin. When you flip a coin, you either get heads or tails. Boom. And after that, this next node, or this little dot, represents the next event. Coin, then it's going to be a die. When you roll a die, there are 6 possibilities. So you do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's 1, 2, 3, 4, 5, 6. Whoa, I messed up somewhere there. 1, 2, 3, 4, 5, 6. So all the possibilities, there are 12. You count 6 here and another 6 here. So the sample space has 12 outcomes. You can use a tree. You can also use a table. For instance, one side is coins. When you flip a coin, you have a possibility of heads and tails. Now when you do a die, you have 1, 2, 3, 4, 5, 6 options. Now make a table of all the outcomes possible with the sample space. You can get heads in 1, tails in 1, heads in 2, tails in 2, heads in 3, tails in 3. You get the idea. And the list, you can just list it out. For instance, you can do You can get heads and then you can get 1. You can get heads and then you can get a 2 on the die. You can get heads and then you can get a 3 on the die. So on, you do that for heads. And the same thing you do for tails. You can get tails and then 1. You get tails and then 2. So these are ways to list the sample space for compound events, which are 2 or more probability experiments. Now, let's do a practice problem. Laura went on vacation, packed 3 pairs of jeans and 5 different tops. How many different outfits can she make? Show the sample space by making a tree diagram, a table, or a list. I'm gonna do a table to show you a way to find out how many different outfits that she can make. If you make a table, well, you have 2 labels. You have jeans and then you have tops. She has 1, 2, 3 jeans and she has 1, 2, 3, 4, 5 tops. If you fill this out, you will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different entries on this table, which is the same thing as the number of pairs of jeans times the number of different tops, which would give you 15. So the sample space can actually be found by multiplying the number of sample spaces for the first option and the number of sample spaces for the second option. So sample space for jeans and sample space for tops, multiply that together and that will give you total sample space. That's what this question is asking you. Now this one's also the same thing. Laura packed 3 pairs of jeans, 5 tops, but also packed 4 different necklaces. How many different outfits can she make? Well, it's actually just 3 times 5 times 4, which will give you 60 different outfits. That's it. That's all you have to do. You have to multiply the number, or you have to multiply the sample space for each option. Sample space for jeans is 3, sample space for tops is 5, and sample space for necklaces is 4. Multiply them all together, you get 60. You guys can do this question by yourself. Now, basic counting principle. Suppose a task involves a sequence of k choices. Let n1 be the number of the ways the first event can occur. Let n2 be the number of ways the second event can occur. Continuing this way, let nk, okay, this is very wordy. Cross it out. This is asking if there are a sequence of k choices where k represents, let's say there was, for the first example, let's go back. This one, there were 2 choices. There was a number of jeans and number of tops. Next one, we have 3 different choices: jeans, tops, and necklaces. That's what we're talking about when they say k choices. If there are a sequence of k choices, then multiply the number of, let's say, events or elements in each sample space together. If there are a sequence of k choices, then multiply the number of events/elements in each sample space together. Okay. So let's go up here. Chef John is trying to perfect his lasagna recipe. He purchases every type of lasagna, noodle, sauce, cheese, mushroom, ground beef, and ground sausage at the grocery store. He found 4 types of lasagna noodles, 18 different sauces, 12 different cheeses, 6 different types of mushrooms, 4 different types of ground beef, and 3 different types of ground sauce. Question asks, if Chef John is going to use one kind of noodle, one type of sauce, one type of cheese, one type of mushroom, one type of ground beef, and one type of ground sausage, how many different combinations could he try? How do you know? Well, there are 1, 2, 3, 4, 5, 6 choices where for the first choice there are 4 types of noodles, there are 18 different sauces, there are 12 different cheeses, there are 6 types of mushrooms, 4 types of ground beef, and 4 types of ground beef and 3 types of ground sausage. If you want to know how many combinations you can try, just multiply the number of elements in each sample space and boom, you're good to go. Where did I get these numbers? 4 different types of lasagna, 18 different sauces, 12 different cheeses, 6 different types of mushrooms, 4 different types of ground beef, and 3 different types of ground sausage. They will generally give you the number of elements in each sample space. That's it. That's all you have to do. Simple. Stupid, simple, stupid. Boom. Please do this practice. Should be pretty easy. All right, you guys are good. Have a nice day. Actually, I'm going to do this question. These two, since they're a little bit not difficult but tricky. Brielle is taking a 5-question personality quiz. Each question has 4 different answer choices. If she answers all 5 questions, how many different possible ways she could have answered the entire quiz? Well, there are 1, 2, 3, 4, 5. 5, what do we call it here? We have 5 events that are occurring. As in 1 question, 2 question, 3 question, 4 question, 5 question. Each of them have 4 different answer choices. If you want to know the different ways that you can answer the quiz, just multiply 4 times 4 times 4 times 4 times 4. That's it. You're done. It's going to give you an answer, though. Make sure you put that in the calculator. Now, second question. A school district gives its students 6-digit ID numbers. The first 2 numbers are always the last 2 digits of the school year the student joined, district, etc. 22. The third is always 0, 1, and the 4th, 5th, 6th digits are randomly assigned. How many different ID numbers are possible? Well, this one has 1, 2, 3, 4, 5, 6 6 events that are occurring. The first 2 numbers are always the last 2 digits of the school year. So these 2 numbers have 100 possibilities because you can go from 0 to 99, and there's 100 choices there. The third is always a 0 or 1, so it only has 2 choices, so there's only 0, 1. And the 4th, 5th, 6th are randomly assigned. That means there's 0 to 9, which means there are 10. How many different ID possibles are possible? So we do 100 times 2 times 10 times 10 times 10, and that should give you the answer. All right, good luck, guys. Thank you so much. I will see you guys tomorrow. Oh wait, before you do that, hit the like and subscribe button. Appreciate it. Bye.